Hi guys, it's Mr. Mustafa here. Welcome to my video presentation on binomial expansion. Before I start, don't forget to like and subscribe to my video channel for more content. Thank you. So let us get straight into binomial expansion. So guys, what is binomial expansion? I'm sure you've seen an expansion like this in school, or something like x plus y to the power 3. And your teacher sometimes they just went and wrote x cubed plus 3x squared y plus 3x y squared plus y cubed. Now, how did they get this? We sometimes when the teacher write this, you as a learner get astonished and you wonder how. So let us answer this question. How we can go straight from here to there instead of doing this x plus y into x plus y into x plus y. So the result of this is basically the same as this. So let us just do it. So if I write x plus y into opening these two up, you will get x squared plus 2xy plus y squared. Now if you take this into this, if you open up this bracket here, 1, 2, 3 terms, then 1, 2, you'll end up with 6 terms, then like terms, of course. So let us open up the first one, product rule. So what we have is x cubed plus 2x squared y plus x y squared. And for the second part, when we multiply y times x squared, we get x squared y. I like to write it at the bottom so we can see the like term. Then y times 2xy, you will get plus 2x y squared plus y times y is y cubed. So this is how we usually open it up. So what we have is x cubed plus 3x squared y plus 3x y squared plus y cubed. So you can see in this long method that the result of this and the result of this, the short method, is basically the same. So what is the short method? This is what we call binomial expansion. Right. Why binomial? Because we are expanding two terms in the bracket, two terms to the power n. So let us have a look. Now, in order to expand x plus y all cubed, let's just write this down again. In order to expand x plus y all cubed and get an answer, we need to understand what is, okay, let me just write down the answer, which is x cubed plus 3x squared y plus 3x y squared plus y cubed. Now, how do we get this? We need to know something called a Pascal's triangle. Pascal's triangle. Right. So Pascal's triangle goes something like this. 1, start with a 1, and you see this expanding this way, you go outwards, and you expand this way, you go outwards. So you form kind of a triangle. So 1, 1. Now, to get this, if you keep on expanding in this direction and this direction, you basically form a triangle. I will show you that in a while. Let me just open this, expand this triangle. So to get this term, we need to add up 1 plus 1. We get 2. Carry on expanding. Then 1 plus 2 is 3. 2 plus 1 is 3. Expand again. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Expand again. Now you can carry on expanding. The next thing is 1 plus 4 is 5. 5 plus 4, no, 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. Let's just do one more. 1 plus 5 is 6. 15. 10 plus 10 is 20. 10 plus 5 is 15. And 5 plus 1 is 6. 1, 1. We can also see that, what we can also see that this triangle is also symmetrical. If you draw a vertical line, you can see it's symmetrical. If you cut it in half, you can see it is symmetrical. Let me just write that one again. You can see coming straight down here, look at these numbers 3 and 3. So if I fold it halfway, these numbers will touch each other. Point of symmetry is 6. So 4, 4, 1, 1. See over here is in the center. There's no number, but 10, 10 touches, 5, 5 touches, 1 and 1 touch. So it is symmetrical along the vertical line. Right. Now, why we said Pascal's triangle? Because Pascal's triangle helps us expand. So this here can be represented as like x plus, let's write it here. What you can say over here is on this side. We can say for that first part is x plus y to the power 0, where the result will just be 0. Sorry, the result will be any x plus y to the power 0, the result will be 1. If you're looking at the next one, you can just write down x plus y to the power 1. The result will just be x plus y. Now, Pascal's triangle helps us to get coefficients, right? Coefficients of binomial expansion. Right. Now, let us look at 1 to 1. So if I write x plus y all squared, I'm looking at this row, the third row, so 1 to 1. So what I can say is this is x squared plus, can you see the first number? Look at these coefficients, is 1x squared plus 2xy plus y squared. See, look at these coefficients. So that's what we said, coefficients of binomial expansion, right? In a Pascal's triangle, we get coefficients of binomial expansion. So 1x squared plus 2xy plus 1y squared. In other words, x squared plus 2xy plus y squared. Then let's look at this one here, x plus y all cubed. We have 1, 3, 3, 1. This will help us get the coefficients. So we can write down 1 plus 3 plus 3 plus 1. Now guys, to get the x and the y, look at the pattern here. If you look at the pattern, look at what's happening here in x squared. I'm looking at x plus y all squared. Look at what's happening here. Observe the powers. This is 2, this is 1, and then what we have here is x to the power 0, which is basically 1. Look at what's happening with the y to the power 0. It starts from 0, then is 1 there, and then y moves on to a 2 there. Understand? So what's happening is that powers of x's, x powers are decreasing from the highest one, which is we start at 2. So we're decreasing the powers of x's, and we're increasing the powers of y starting from 0. So we're decreasing from n down to 0, and y we're increasing from 0 to n. Now, so expanding x plus y all cubed, we will start with 1x cubed y to the power 0, which is 1. Then 3x squared y to the power 1. Then 3x to the power 1 y squared. Then 1x to the power 0 y cubed. So my answer is x cubed plus 3x squared y plus 3xy squared plus 1y cubed. Now, let us just carry on with this expansion. Now, if I have to look at the next one, which is x plus y to the power 4, then what I can write here is x to the power 4 plus, look at the coefficients in this row, x to the power 4, 1x to the power 4 plus 4x cubed. I'm decreasing the powers of x's, and then y, because this was y to the power 0 and this is y to the power 1, plus 6x squared y squared plus 4x y cubed plus y to the power 4, because we have x to the power 0, y to the power 4, 1 at the end. Next one, if you have to expand x plus y to the power 5, just write it here, x plus y to the power 5, we will get x to the power 5 plus, you're looking at this row, which is x plus y to the power 5. This is x plus y to the power 6, looking at this row. We will get x to the power 5 plus x to the power 4, 5 x to the power 4 y plus 10 x cubed y squared plus 10 x squared y cubed plus 5 x y4 plus y to the power 5. So this is, now the problem arises if we do this. What happens if we have x plus y to the power 11 or x plus y to the power 40? X plus y to the power 40. How are we going to get coefficients? How will we get the coefficients? How will we get the coefficients if we have x plus y to the power 40? If you look at, if we observe the coefficients in x plus y, let's start with the x plus y to the power 3. So we can actually get a formula for coefficients. This is where binomial expansion will basically fail you if you have x plus y to the power 40, if you have to start off with Pascal's triangle. Now, if you look at x plus, let's just go back and look at x plus y all cubed. That's what I've started off with. Now, x plus y all cubed, if you write down x plus y all cubed, I'll get back to this example. X plus y all cubed is equal to x cubed, which is 1x cubed, plus 3x squared y plus 3x y squared plus y cubed, which is 1y cubed. Now, these coefficients are modeled by something called a combination. Look at these coefficients here, 1, 3, 3, 1. So what we can write here is the coefficients are found by combination, something called a combination. Now, what is a combination? Combination is defined by NCR, where we have n factorial over r factorial into n minus r factorial. Just to understand this, let's look at what is, or we can also read it as n choose r, right? So n choose r. So if I say 5 choose 2, I would say 5 factorial over 2 factorial into 5 minus 2 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. So basically a factorial is product of descending natural numbers. Natural number obviously starts from 1. So 5 times 4 times 3 times 2 times 1. This is 2 factorial is 2 times 1. And then 5 minus 2 factorial, which is 3 factorial, is 3 times 2 times 1. So I can take out a 2 and a 2, a 3 and a 3. I can cancel them out. So what I'm left with is 5 times 4, which is 20, divided by 2, which is equal to 10. Now let us just understand what we have done here. 5 choose 2. In other words, if we go back to the Pascal's triangle and look at the expansion for x plus y to the power 5, because remember we said this 5 is n. Let us go back to the Pascal's triangle. X plus y to the power 5, we're saying choose 2. So x plus y to the power 5, we have coefficients, which is 1. 1 will be 5 choose 0. This 5 will be 5 choose 1. And this 10 will be 5 choose 2. And this 10 will be 5 choose 3. And this 5 will be 5 choose 4. And this 1 will be 5 choose 5. Now, so if I have to go and expand x plus y to the power 3, I will start off with 3 choose 0, x to the power 3, y to the power 0, plus 3 choose 1, x squared y 1, plus 3 choose 2, x y squared, that's x1, plus 3 choose 3, x 0 y to the power 3. Now what we can see is, can you see that 3 plus 0 is equal to 3? Can you see there's 2 plus 1? These are all patterns that you can observe. 2 plus 1 is 3. 1 plus 2 is also 3 there. And then 0 plus 3 is 3 there. Now 3 choose 0. If I have to go and find what's 3 choose 0, I will say that is 3 factorial over 0 factorial into 3 minus 0, which is 3 factorial. 3 factorial cancel out. 0 factorial is defined as 1. So what we have is just 1 there. Then 3 choose 1 is going to be 3 factorial over 1 factorial over 2 factorial. So 3 to 1, 2 times 1, 2 times answer is 3 there. Then 3 choose 2, I will have 3 factorial over 2 factorial, 1 factorial. Is basically the same as the previous one, 3 choose 1, 2 factorial, 1 factorial in the denominator. I will get an answer of 3. Then 3 choose 3, guys. 3 choose 3 is 3 factorial over 3 factorial, 0 factorial. Why 0? Because 3 minus 3. And you can see everything cancel out. The answer is 1. So what we can say is that x plus y all cubed is equal to 3 choose 0 is 1. So x cubed plus y to the power 0 is 1. 3 choose 1 is 3, x squared y plus 3 choose 2 is 3x y squared plus y cubed. Since 3 choose 3 is As you can see here, 3 choose 3 is 1. Now, suppose we want to find x plus y to the power 20. The question is, how? How should we go and find x plus y to the power 20? Because the Pascal's triangle will be very tedious, where you have to go up to approximately 20 or 21 rows. So let us have a look at, from combinations, how we can make up a formula for x plus y to the power 20. So what we can say is x plus y to the power 20 is equal to the sum of, we can write a counter here. We choose a counter which is k equals 0 to 20. Of course, we're doing 20, choose k, x to the power. Remember, we go from the highest power down to the lowest power, which is x to the power 20 minus k, and then y to the power k, where these represent the terms of the expansion. If we look at, if we have to expand these terms, if k is equal to 0, then what we have is 20 choose 0, x to the power 20, y to the power 0. And we know that 20 choose 0 is 1. So we just have x to the power 20. How we know 20 choose 0 is equal to 1? Because that's 20 factorial over 0 factorial, 20 factorial. That and that cancel out. 0 factorial is defined to be 1, so the answer is 1. Now, if k is equal to 1, we will have 20 choose 1, x to the power 19. It will be x to the power 19, because using this formula is 20 minus k, y to the power 1. So you will have, doing something similar to this, you will have 20 x to the power 19 y. So guys, we can see that this is an easier method, and you can continue. So we can write x to the power 20 plus 20 x to the power 19 y plus dot dot dot, and then y to the power 20, where all the middle, we have some terms in the center. Obviously, altogether, important to note is that altogether there are 21 terms. So we can actually go and make up the terms formula. So I call it T k plus 1 is equal to, because we can't say term 0, we usually start from term 1. So we will let k equal to 0, which will give us term 1. K equals 2 will give us term 3. Just say k equals 5 will give us term 6. So what we can say is that term formula should be without the sigma notation, because we are looking at a specific term. So what we can say is that in general, we can say n choose r, sorry, n choose k, since my counter is k, x to the power n minus k, y to the power k. Or we can also write it in this way. We can also say n choose k, y to the power k, x to the power, sorry, we can say x to the power k, y to the power n minus k. Since it is symmetrical, that's the reason why we can say, we know from the Pascal's triangle that the coefficients are symmetrical. Now, if you have to look at another expansion, an example, how will we go and expand? Before we expand, let us write down the general formula. What is the general formula for binomial theorem or expansion? So the general formula is x plus y. We can say this here is equal to x plus y to the power n is equal to n, choose r, x to the power n minus r, y to the power r. In this case, r is my counter, 0 to n. This n choose r can also be written as n factorial over r factorial into n minus r factorial, which is n choose r. Sometimes it's also denoted in this notation, n choose r. Now, looking at an example, let me give you an example. Let us try to expand this 2x minus 3y to the power 6 using binomial theorem. So solution, what we can say is a plus b to the power n, where my a is equal to 2x, my b is equal to minus 3y, and my n is equal to 6. So substituting this into the formula, I will get k equals 0 to 6. Sorry, let me write down 2x minus 3y. I write down 2x minus 3y to the power 6 is equal to k equals 0 to 6. 6 choose k. 2x to the power 6 minus k minus 3y to the power k. Now, very important here is to group coefficients and variables. So let us group the coefficients and variables. What are coefficients and what are variables in 2x minus 3y to the power 6? 2x minus 3y to the power 6 is equal to k is equal to 0 to 6. 6 choose k will be my coefficient. That's a coefficient. Look at 2. So we will have 2 to the power 6 minus k. That's also my coefficient. And then minus 3 to the power k. that will also be my coefficient. And my variables are x to the power 6 minus k, y to the power k. Now, let us go and expand this. So if, obviously, I need all the values for 6 choose 0, 6 choose 1. So what we know is that 6 choose 0 is equal to 6 factorial over 0 factorial 6 factorial, which is equal to 1. This is also equal to 6 choose 6. Then 6 choose 1 is also equal to 6 choose 5, which is equal to 6. Then 6 choose 2, which is equal to 6 choose 4, which is equal to 6 factorial, 2 factorial, 4 factorial, which is equal to 6, 5, 4 factorial over 2 factorial, 4 factorial. 6 times 5 is 30 divided by 2, which is equal to 15. Now we need 6 choose 3. 6 factorial over 3 factorial, 3 factorial. So we have 6, 5, 4, 3 factorial, and then 3, 2, 1, 3 factorial. 3 factorial, 3 factorial cancel out. 3 times 2, which is 6, and 6 cancel out. 5 times 4 is 20. Now, we have all these. So what we can say is 2x minus 3y to the power 6. 2x minus 3y to the power 6 is now equal to 6 choose 0 is 1. 2 to the power 6. So you can write 2 to the power 6, which is equal to 64. Minus 3 to the power 0 is 1. 6 to the power x to the power 6, y to the power 0. Now, the next term is important. Look at this, minus 3. The terms usually alternate because of the negative sign. If it's a plus, then all the terms will be positive. If there's a minus in the center, the terms alternate from positive, negative, positive, negative. So we can put a minus there. Then, okay, let us just put a plus, and then you'll see how it becomes a minus. So 6 choose 1 is 6. 2 to the power 5 is 32, then times 3, of course, negative 3. X to the power 5, y, plus 6 choose 2 now. 6 choose 2 is 15. 2 to the power 4, which is 16, minus 3 squared. X to the power 4, y squared, plus 6 choose 3, which is 20. 2 to the power 3, which is 8, and then minus 3 cubed. X to the power 3, y to the power 3, plus. So we've got 0, 1, 2. So this was when k was equal to 0. This was when k is equal to 1, k is equal to 2. This is when k is equal to 3. Now when k is equal to 4. When k is equal to 4, we have 6 choose 4. 6 choose 4 is equal to 15 here. And then 2 to the power 2, which is 4, minus 3 to the power 4, x squared, y 4, plus when k is equal to 5, we have 6 choose 5. 6 choose 5 gives us 6. 2 to the power 1, 3, minus 3 to the power 5, x, y to the power 5. Continuing like this, we have the last one, plus 1, because 6 choose 6 is 1. 6 choose 6 is equal to 1. And then let me just get back to the formula. 2 to the power 0, which is 1 as well. So we have minus 3 to the power 6, x to the power 0, y to the power 6. And simplifying all these should give us, the important thing to note here is that we are getting alternating signs. So we have 64 x to the power 6 minus subtract. If we multiply all this out, we should get minus 18 times 32, which is minus 576 x to the power 5 y plus y plus, because we have a minus 3 squared. So that's 9. We have 15 times 16 times 9. That will give us 2160 x to the power 4 y squared. Then the next term should be a negative because of negative 3 cubed, which is going to give us 27 times 8 times 20, which is going to give us 4320. Guys, these numbers over here, we don't usually need to multiply them all out for large powers of n. If the powers are too large, we do not need to multiply everything out because it becomes like really tedious. Now, minus 4320 x cubed y cubed plus, yes, the next term will be a plus 15 times 4, which is 60 times 3 to the power 4, which is equal to 81. So we are getting 4860 x squared y to the power 4 plus, not plus, should be a minus, minus, we are getting 6 times 2, which is 12 times 3 to the power 5, 2916 x y to the power 5. And then minus 3 to the power 6 is positive 729 y to the power 6. So this is the expansion for 2x minus 3y to the power 6. Very important to note here is that the signs are alternating. So important to note is alternating signs. And also important to note are some patterns in this binomial expansion. Let's look at some patterns. Yeah, we can see 5 plus 1 is 6. That's y to the power 1. You can see 4 plus 2 is also 6. 3 plus 3 is also 6. 6, 5, and 1. That also gives us 6. X squared y4. That also gives us 6. So the sum of the powers on the variables gives us basically that value there. Now the important thing to note is that powers of x decreases from 5, from 6 down to 0 in the terms from 6 to 0, and powers of y increases from 0 to 6. As we can see here, y to the power 0, y to the power 1, 2, 3, 4, 5, 6. I hope you understand this problem. If you do not understand this, try to pause the video and see how I've done this. Let us find the, let us have a look at the, let us look at, have a look at an example where we can say in 2x minus 3 over x squared to the power 25. Find the term that contains x to the power minus 13. So solution, what we can say is 2x minus 3 over x squared to the power 25 is equal to sigma k equals 0 to 25. 25, 25 choose R. 25 choose K, sorry, we are using K. Your A value, try to choose A and B values. So what we can say here is 2x to the power 25 minus K minus 3x to the power minus 2 to the power K. If I'm choosing this as A and my B value here, which is with the sign, I can take this x squared on top, it becomes 3x to the power negative 2. Now, let me just take this out and put it into the term formula. So tk plus 1 is equal to 25 choose k, separating the variables and the coefficients, 2 to the power 25 minus k minus 3 to the power k. These are my coefficients and these are my variables. Variables are x to the power 25 minus k dot x to the power minus 2k. Now, this here should be equal to x to the power 13. Sorry, let me just make this positive 13. Otherwise, if I have a negative 13, it will not work out. So therefore, since we want to find the term that contains x to the power 13, obviously we need to get the value of k. What is k equal to? If we know what the value of k is, then we can recover the term. So to solve this problem, let us look at the bases here. We have x to the power 25 minus k minus 2k is equal to x to the power 13. We can drop the base here, equating coefficients basically. That's how we solve this problem here. So we have 25 minus 3k is equal to 13. Which is minus 3k is equal to 13 minus 25, which is minus 12. Therefore, k is equal to 4. Now, if k is equal to 4, we can recover the coefficients because we already know if k is equal to 4, we have 25 minus 4, which is 20, or sorry, if k is equal to 4, we can just substitute it in here. 25 minus 3 times 4, which is 12. We will get 13x to the power 13. We just need to recover what is the coefficient. So the coefficient is 25, choose 4. Let us find the value of 25, choose 4. The coefficient is this entire thing here. So we have 25 factorial over 4 factorial, 21 factorial. So we got 25, 24, 23, 20, missed a few here, should be 22 dot 21 factorial over, so 25, 24, 23, 22, 21 factorial over 4, 3, 2, 1, and 21 factorial. 21 factorial, 21 factorial cancel out. 4, 3, 2. 4 times 3 is 8, 4 times 3 is 12, times 2 is 24, and 24 cancels out. Then we have 25 times 23 times 22. Therefore, coefficient. Therefore, the full term is equal to, obviously we have x to the power 13 there. The coefficient is thus 25 times 22 times 23 times 22 times 2 to the power, we said k was 4, 2 to the power 21, and minus 3 to the power 4. Minus 3 to the power 4. We can simplify further. We can see how large this number is because of 2 to the power 21. So we can simplify it in exponents. So 25 is 5 squared. 23 is prime number. 22 is 2 times 11. This is 2 to the power 21. And this is 3 to the power 4. X to the power 13. So my final answer, we can take this 2 and group it up there. And 5 squared, which is 25. So what we have here is 2 to the power 22, 5 squared, 3 to the power 4, all the powers first. We have a 23, and we have an 11, which is a prime number, x to the power 13. And this is our final answer, because the question says in 2x minus 3 over x squared to the power 25, find the term that contains x to the power 13. So the term that contains x to the power 13 is this entire term here. The question did not ask for the coefficient only, the entire term. Thank you. I hope you enjoyed this video, and make sure to watch my next video on examples of binomial distribution. These are very simple examples. Please make sure to like and subscribe my video as well.